Everyone loves the idea of parallel universes. Maybe it's the appeal of an ideal world where you have second chances and things turn out differently. An alternate reality where you do get into Hogwarts and the Star Wars prequels aren't made and you finally plug in your asymmetric computer code correctly on the first try. But is there really a place in science for such wistful speculation? I mean, if the universe is everything that there is, you can't have two versions of it, right? Otherwise the pair would really be everything and what you started off calling the universe wasn't. The problem here is terminology. Physicists speaking informally often say universe when they really mean observable universe. That is, the part of the whole universe that we've so far been able to see. And it's perfectly fine to talk about multiple different observable universes. For example, an alien near the edge of our observable universe will see parts of the whole universe that we can't yet see, because the light hasn't had time to reach us yet. But that's a well-understood question, and not what physicists normally talk about when they discuss multiple observable universes or multiverses. So let's cut to the chase. In physics, the word multiverse normally refers to one of three distinct and largely unrelated proposed physical models for the universe, none of which has been tested or confirmed by experiment, by the way. The three multiverse models are Type 1, bubble universes or baby black hole universes. This is the most straightforward kind of multiverse. The basic idea is that perhaps there are other parts of the universe which are so far away that we will never see them, or are inside black holes, so similarly we will never see them. This kind of model was created as an attempt to explain why our universe is so good at making stars and galaxies and black holes and life. As the argument goes, if each of these separate mutually unseeable bubbles in the
universe had slightly different laws of physics, then by definition we could only exist in one that had the right physical laws to allow us to exist. Like, we have to live in a universe where the Earth could form, because if the Earth couldn't form, then we couldn't be here. If you're not convinced by this logic, don't worry too much. There's not yet any experimental evidence for this kind of multiverse. Multiverse Type 2. Membranes and extra dimensions. Inspired in part by the inability of the mathematics of string theory to predict the right number of dimensions for the universe we observe, string theorists